Welcome, learners. My name is Mr. Pochilola, your teacher on this platform. This is Black Slides Online Secondary School, the place where you learn the sciences, such as physics, chemistry, biology, agriculture, and mathematics. So we meet now for our Form 3 physics lesson. We are going to dwell on measuring small time intervals using a pendulum and the cathode ray oscilloscope. Welcome, learners. So if this is the first time you are watching our video lessons on YouTube, consider subscribing to the channel, Black Slides Online Secondary School. So subscribe, hit the notification bell so that every time we upload material on this channel, you are informed. Or you may consider joining our main classroom, where you have full access to papers, to video lessons, mock papers, money papers, notes, textbooks, and many other materials. We have hundreds and hundreds of materials there. So welcome once again. We are discussing how to measure small time intervals using a pendulum and the cathode ray oscilloscope. So by the end of this lesson, you should be able to explain why ordinary stopwatches are not suitable for measuring very small time intervals. You should be able to describe how a simple pendulum can be used to measure time. Explain how a cathode ray oscilloscope measures very small time intervals. How calculate small time intervals using the time-based setting of a cathode ray oscilloscope. Then state the advantages and limitations of using a pendulum and the cathode ray oscilloscope for measuring time. So these are the objectives that we intend to achieve at the end of this lesson. Welcome, learners. Recall that time is one of the basic quantities in physics, and it is such an important physical quantity. Basically, time is the duration between two events, measured in minutes, seconds, and the other units of time, such as the milliseconds and microseconds. So while a stopwatch is suitable for measuring seconds or minutes, it is not accurate enough for very short time intervals such as milliseconds or microseconds. So instruments such as a pendulum and the cathode ray oscilloscope provide more accurate measurements than the stopwatch. So we're saying ordinary stopwatches are not suitable for measuring very small time intervals. For many experiments in physics, a stopwatch could be enough to measure time. But considering that the human reaction time is about 0.2 seconds, this reaction time causes large errors when measuring intervals shorter than 1 second. That's where a stopwatch fails. So very short events require electronic measuring instruments. Examples include vibrations, electrical signals, and sound waves. Therefore, more accurate methods are needed. That's where we are going to explore on the use of the pendulum and the cathode ray oscilloscope to measure very small time intervals. Welcome, learners. So let's explore measuring time using a pendulum. A simple pendulum consists of a small metal bulb, a light string, and a fixed support. This is what a pendulum looks like. So it has a mass, which is called a bulb, B-O-B, attached to a string, which is attached to a rigid support, so that when you set this up, initially the string, the mass, are going to be vertical along this passage. So this position is called the mean position, also known as the equilibrium position. So when you displace it slightly and release it, it is going to oscillate. So you push this, that's this side, and release it, it's going to oscillate. To oscillate means to move to and fro, to and fro, to and fro. This movement is called an oscillation. So it's going to do so as long as there's nothing to stop it. It's going to oscillate, to move to and fro, to, fro. That's called oscillation. All right, so there are times when we are required to determine the time that the mass moves from this position here to that end and back. The path taken to move from here to the other end and return to that starting position is called a complete oscillation. So the time it takes to move from this point to that end and back, the time is called period. It's called period or periodic time. So the time taken for one complete oscillation, which is to move from here to that end and back, is called a period, denoted by the letter T, capital T. Welcome, learners. So if you have not subscribed to the channel, please consider to do so. And also remember to hit the notification bell. This will help you every time we upload a new material. You'll be notified. So that's the simple bulb, the pendulum. So in order to work out the time for complete oscillation, you simply count a certain number of oscillations, let's say 20 of them. So you count 1, 2, 3, 4, up to 20, and it notes the time taken for those oscillations to be made. So you do this while the stopwatch is ticking. All right, the moment you release it from here, from the initial position, this to this end, you start the stopwatch, and while the stopwatch is ticking, count the number of oscillations up to 20 of them. Remember, one oscillation is from here to that end and back. So you have 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on up to 20. And then when it stops, you record the time taken to make those 20 oscillations. So dividing the total time taken by the number of oscillations will give you periodic time. So that's how you would measure time interval for a complete oscillation. Let's say, for example, a pendulum makes 20 oscillations in 40 seconds. So to find the period, you divide the number of seconds, which is the time, 40 divided by the number of oscillations. So period is going to be 2 seconds. Therefore, one oscillation takes 2 seconds. So these 2 seconds are called period. Some precautions while we carry out this experiment. You need to use a small angle of swing. This angle doesn't have to be too large, just to displace it a little bit. Because if you push it higher, then you have a large amplitude. Your thing will not function well. Okay, so just to displace it a little bit and let it swing on its own. So you're saying use a small angle of swing, measure many oscillations to reduce errors. Don't base your calculation on just a few oscillations. You need to have as many oscillations as possible. I chose 20 oscillations, and then you record the time for that, which you can use to find period. So period is simply time taken to make that number of oscillations divided by the number of oscillations. So measure many oscillations to reduce errors. You also have to avoid air current. So don't do this experiment on a windy environment, say outside the lab where the weather is windy. So avoid air currents, because that can increase the magnitude of errors. When do you start counting? Start counting after the pendulum swings steadily. So don't just start counting immediately you displace this. When you displace it to that end, let it swing for a number of times until it starts to oscillate steadily. Then you start counting 20 oscillations and record the time taken to make those 20 oscillations. Then divide the time taken by the number of oscillations. It will give you time, which is called period. Welcome, learners. In your exams, MSCE exams or KCSE exams, or whatever O-levels exams, you'll be asked a question, maybe in paper 2, for example, if you are in Malawi, paper physics, paper 2, has descriptive questions 1 and 2. Or if you are in Kenya, it could be paper 3, or slightly maybe paper 2. I'm not sure which one. All right, so this is according to MANEB. You'll be asked a question which says that with the aid of a well-labeled diagram, describe an experiment that could be done to determine the period of an oscillating pendulum. All right. In other words, the diagram is going to look like this. So remember, I've always said that when you draw a diagram correctly, before you label it, that's 1 mark. When you label at least 3 parts, you have 2 marks. So together, the diagram alone can give you 3 marks. So you can't afford to lose 3 marks just on the diagram. So draw neat diagrams. Don't draw awkwardly looking diagrams. Examiners sometimes, because of attitude or something else, they may not mark your poorly drawn diagram happily. Okay, so draw a neat diagram, label it nicely so that you get 3 marks right away before you start describing. Alright, so you draw a diagram like that. You are answering a question that says, describe an experiment that can be done to determine the period of a simple pendulum. Okay, so you begin by saying, set up a simple pendulum by suspending a small metal bulb from a fixed support using a light string and measure the length of the pendulum. So using a ruler, you measure this length of the string. This is the length in question. Displace the bulb, which is the mass, through a small angle. You can estimate the angle should be less than 10 degrees. This angle here we are talking about with respect from the resting position, this one. So this angle should be small enough, not too big. So displace the bulb through a small angle, less than 10, and release it gently without pushing it. So release it. When you displace it to that end, just let it move by itself. Don't push it with your hands this way. No, just let it there. Once you displace it, leave it. It's going to start oscillating like this, like that. Start a stopwatch as the bulb passes the mean position and count a large number of complete oscillations. For example, you can take 20, 30, 50, yeah, but not small number, because small number can lead to errors. Then stop the stopwatch after the chosen number of oscillations and record the total time taken. So when it has made 20 oscillations, you can stop the stopwatch. So you calculate the time for one oscillation, which is called the period, using the formula period is equal to total time divided by number of oscillations. Repeat the experiment several times and calculate the average period to improve the accuracy of the measurement. So if the average period is calculated from many oscillations, then the time interval of one oscillation is measured more accurately using the pendulum. Welcome, learners. This is Black Slides Online Secondary School, your school. Invite your friends to join us, either by subscribing to this channel or by enrolling into our school, online school, where you have full access to hundreds and hundreds of materials there. Welcome, learners. Welcome to the CRO, commonly known as the Cathode Ray Oscilloscope. We are not going to describe its internal structure because that's not the interest of this lesson. We'll simply go ahead to discuss how you can use it to measure time intervals, small intervals. So measuring small time intervals using a cathode ray oscilloscope. A cathode ray oscilloscope is an electronic instrument used to display electrical signals on a screen. So it has a screen. So the horizontal movement of the beam, which is the beam of electrons, is controlled by a button which is called time base. The time base is measured in seconds per division, milliseconds per division or microseconds per division, where division means div means 1 square or a division on the screen, something like this. So this is a cathode ray oscilloscope when you're looking at it from the front. So it has these features, the buttons. There's time per division and volts per division. That's why later on you will learn that a cathode ray oscilloscope can be used to measure small time intervals or frequency of a wave. It can also be used as a voltmeter to measure voltage. So this button is used to set it to measure voltage. But our interest is how this can be used to measure very small time intervals. And then it has these ports. We have the wire inputs, and this is what is called the external trigger terminal. It has the intensity control, the intensity of the beam, and then it has a power button for turning it on and off. Your observations are made on this screen. Just quickly, so the screen, this one here, which is also called the CRT, the cathode ray tube display, displays an electron beam trace, which is a waveform of a spot. So the spot moves in the form of a wave like this. And then we have a time-based button over here, labeled time per division. This controls the horizontal speed of the sweep, the horizontal speed of the movement of this waveform. It determines the time represented by 1 division on the screen. Divisions are these small boxes which you see. And then we have a Y amplifier, which is volts per division, representing volts per division. This controls the vertical sensitivity. As this waveform if the beam is moving this way, it also has vertical displacements up and down, up and down. So this determines the voltage represented by 1 division on the screen. And then we have buttons like focus control, which is used to obtain a sharp and a clear trace on the screen. We have the wire input terminal, this one here, which is used to connect the electrical signal whose waveform is to be measured or observed. Let's say you are trying to observe to the frequency of a sound wave. So you plug your input there, maybe the microphone or something. And then we have an external trigger terminal used to synchronize the sweep with the input signal. And then we have the intensity control. This one here adjusts the brightness of the trace on the screen, increasing the brightness for easy observation. And then this one is obviously power button, which switches the oscilloscope on and off. So that's the cathode ray oscilloscope. We can use it to measure very small time intervals. Okay. So in order to calculate a time interval, you use this formula. A time interval, that's the time between events, is equal to number of divisions. Just count the number of divisions. You count these divisions. These ones, 1, 2, 3. You can easily count these 1, 2, 3, 4, 5, 6, and so on. All right. So number of divisions times time-based setting. All right. So you can set the times using this button here. Let's say you set it so that every division is 2 seconds, or every division is 2 milliseconds. Okay, so to find the time interval, just take the number of divisions that have been occupied by the waveform multiplied by the setting time, the set time. Right? So we're saying time interval is time number of divisions times time-based setting. Let's say, for example, the time for each division represents 2 milliseconds, and the signal occupies 4 divisions. Then the time interval is just 4 times 2, which is 8 milliseconds, as simple as that. So we're saying, suppose that each division is 2 milliseconds, and the signal occupies, let's say, 4. 1, 2, 3, 4. So the time interval will be 4 times 2. 2 is the time base for each division. Let's suppose that the time base is equal to 0.5 milliseconds per division. Each of these divisions is 0.5 milliseconds, and suppose that the signal occupies 6 divisions. Let's say 1, 2, 3, 4, 5, 6. So the time interval is going to be this 6 multiplied by 0.5. That's 3 milliseconds. That's how you can use the cathode ray oscilloscope to measure time intervals. So easy. Welcome, learners. This is Black Slides Online, the place where you learn these sciences. Don't go wrong on choosing where to learn. Welcome to Black Slides. Invite your friends. If you're a parent and you have children who are doing physics, chemistry, biology, agriculture, and mathematics, consider arranging for them online lessons with Black Slides Online. That's where they learn fully, covering the syllabus honestly and earnestly. Alright, so let's explore the advantages and limitations of each one of these methods of measuring very small time intervals. A pendulum, as a means of measuring very small intervals, has the following advantages. Namely, it is simple to construct, very simple to construct a pendulum. Just need a bulb, a light string, attach it to a support, you are done. Your set is cheap. Good for measuring intervals of several seconds. And is very useful in school laboratories. However, it has limitations or disadvantages that is not suitable for milliseconds or times less than a second. It can be affected by air resistance. That's why with time it is going to stop oscillating because of air resistance. Remember that the human reaction time is 0.2 seconds. So human reaction time introduces errors. Sometimes you may not count the number of oscillations as accurately as possible. So it will bring in errors in your experiment. Welcome, learners. The cathode ray oscilloscope has advantages as well as limitations or disadvantages as measuring instrument. Advantages are that it's very accurate and it measures milliseconds and microseconds very easily. It displays electrical signals clearly on the screen. It has a screen, and there's no human reaction error involved there. The limitations of a cathode ray oscilloscope are that it is very expensive. It costs quite a fortune to buy a cathode ray oscilloscope. It's very expensive. Last time I checked, it was even up to 10 million Malawi kwacha. That's a lot. It requires electricity, so this cannot be used in a place where there's no electricity. It needs proper adjustment before using it, so it needs someone who is experienced and has the knowledge of how to operate it, to adjust it, or operate it so that it can be used. It's not just plug and play instrument, no. You need to set it properly before using it. So these are the limitations. So know the advantages and disadvantages of each of these. So in summary, we are saying a stopwatch is unsuitable for measuring very small time intervals because of human reaction time, which is 0.2 seconds. So a pendulum measures time through its period of oscillation, and the period of a pendulum can be calculated using the formula period equals to total time taken divided by the number of oscillations. In order to calculate the time interval on a CRO, use this formula. Just take the number of divisions multiplied by time base setting. This is how far I wanted to take you. But before I go, I would like to leave this work, which you have to do, and share with me the responses. This is your exercise. So a pendulum makes 25 oscillations in 50 seconds. Calculate its period. A CRO is set at 5 milliseconds per division. A pulse, which is a signal, occupies 3 divisions. Calculate the time interval. State 2 advantages of using a CRO instead of a stopwatch. Why is it better to measure the time for 20 oscillations than for 1 oscillation using a pendulum? State 2 limitations of using a simple pendulum to measure time. Limitations are like disadvantages. Welcome, learners. So my name once again is Mr. Pochilola, expecting to see you next time. Bye bye for now.